In September 1977, a spacecraft the size of a small car was launched from Cape Canaveral with a mission plan calling for 5 years of work and then, effectively, retirement. Fly past Jupiter, fly past Saturn, send back photographs, go dark. Nobody planned for anything more. Nearly half a century later, Voyager 1 is still alive. It is the farthest human-made object in existence, more than 24 billion kilometers from Earth, moving at 61,000 kilometers per hour into the galaxy. It crossed the boundary of our solar system in 2012, an event that required scientists to rewrite their models of where our star's influence ends. And in the years since, it has been detecting something no instrument had ever recorded: a steady, low hum resonating through the plasma between the stars. This is the story of how a limited mission became an infinite one, and what it found along the way. If you find value in what we explore here, please like and subscribe. It tells the algorithm this content is worth sharing and helps us reach the people who need to see it. Voyager 1's improbable trajectory traces back to a piece of orbital geometry that occurs with extraordinary rarity. Every 175 years, the outer planets align on the same side of the Sun in a configuration allowing a spacecraft to visit all of them in a single mission, using each planet's gravity as a slingshot to the next. In the late 1960s, NASA engineer Gary Flandreau identified this alignment and proposed what became the Grand Tour. Voyager 1 and its twin, Voyager 2, were built specifically to exploit it. Voyager 2 launched first on August 20th, 1977. Voyager 1 followed on September 5th, on a faster trajectory that allowed it to overtake its twin within weeks. Just 13 days after launch, while more than 11 million kilometers from Earth, Voyager 1 turned its camera backward and captured the first photograph ever taken of Earth and the Moon together from deep space. Two worlds suspended in black nothing. It was an early signal that this mission was already exceeding its original intent. Voyager 1 arrived at Jupiter in March 1979 and dismantled a century of assumptions in days. The Great Red Spot, long visible from Earth, was confirmed as a counterclockwise hurricane wider than Earth itself, with winds exceeding 600 kilometers per hour, spinning continuously for centuries. Jupiter's ring system, unknown before Voyager, was discovered almost by accident. 4 new moons were identified. The defining shock came from Io, active volcanoes erupting in real time, the first ever observed beyond Earth, driven by tidal heating from Jupiter's immense gravitational pull. And Europa's smooth, fractured ice surface bore a striking resemblance to broken sea ice, implying that a liquid ocean, kept warm by the same tidal forces, might exist beneath kilometers of ice. The implications for life beyond Earth were immediately recognized and have not diminished since. At Saturn in November 1980, Voyager revealed its ring system to be not 3 broad bands, but thousands of distinct dynamic ringlets sculpted by embedded moons. The mission-defining encounter was with Titan, Saturn's largest moon and the only one in the solar system with a thick atmosphere. Voyager's instruments found that Titan was cold enough, minus 179 degrees Celsius, for methane to cycle through solid, liquid, and gas phases, just as water does on Earth. Methane rain, methane rivers, a chemistry unlike anything previously imagined. To study Titan closely, mission planners chose a flyby trajectory that deflected Voyager 1 out of the solar system's plane permanently, ending its role as a planetary explorer. In exchange, it was now aimed at something no spacecraft had ever reached: the true edge of the Sun's domain. The Sun continuously exhales charged particles, the solar wind, inflating a vast bubble in interstellar space called the heliosphere. The boundary where this bubble ends is the heliopause. Before Voyager crossed it, scientists expected a gradual transition, the solar wind thinning slowly, cosmic rays increasing slowly, over a broad, diffuse zone. The data told a different story. On August 25, 2012, the transition happened abruptly. Solar wind particle counts dropped sharply. Galactic cosmic rays surged. The magnetic field's character shifted. Over roughly 2 days, Voyager 1 passed from one domain to another, as if crossing a membrane, sharp, defined, and unexpectedly thin. It was the first time in history that a human-made object had entered interstellar space, confirmed by NASA in September 2013. What Voyager found on the other side was not emptiness. The interstellar magnetic field was 2 to 3 times stronger than models had predicted, pressing on the heliosphere with roughly 10 times the anticipated force. Our solar system's protective bubble is more compressed than we assumed. The galaxy pushes back harder than we knew. Among all Voyager's discoveries in interstellar space, one stands apart for its strangeness. A persistent, low-frequency hum at around 3 kHz, detected continuously across 3 years of observation between 2017 and 2020. It was not a burst or a pulse. It was a steady background tone, faint, unwavering, and present wherever the spacecraft listened. Scientists identified it as plasma wave oscillations, electromagnetic waves traveling through the ionized gas filling interstellar space. The frequency of those waves directly encodes the density of the plasma. By analyzing Voyager's signal, researchers measured the electron density of the interstellar medium at roughly 0.055 electrons per cubic centimeter, a value long theorized but never directly confirmed. Voyager 1 is not merely traveling through interstellar space, it is measuring it from the inside. The hum is the universe's own ambient electrical noise, the quiet, persistent resonance of the galaxy's local bubble, the cavity 1,000 light-years wide carved out by ancient supernovae in which our entire solar system resides. Voyager 1 carries less than 70 kilobytes of total memory. Its data is recorded on 8-track magnetic tape. Its transmitter runs at 22.4 watts, the power of a dim refrigerator bulb, and by the time that signal crosses 24 billion kilometers to reach Earth, it arrives with a power of roughly 10 to the minus 17 watts, detectable only by the planet's largest antenna dishes. 3 radioisotope generators, converting the decay heat of plutonium-238 into electricity, now produce approximately 249 watts combined, enough for a few light bulbs. NASA has been shutting down instruments for years to keep the most critical systems alive. In November 2023, Voyager 1 began transmitting nonsense, undecodable binary noise traced to a memory chip failure in the flight data system. The repair required rewriting 1970s-era software to route around the corrupted region, splitting unified code into pieces stored in non-contiguous, healthy memory. Every command took 22.5 hours to arrive. Every response took 22.5 hours to return. On April 18, 2024, the repaired code was transmitted. On April 20th, after 45 hours of silence, Voyager 1 responded with coherent telemetry. All 4 remaining science instruments were confirmed functional. A resurrection, performed across 24 billion kilometers of space on hardware built half a century ago. Attached to the spacecraft's exterior is a 12-inch gold-plated copper disc, the Golden Record, assembled in 1977 under Carl Sagan's direction. It contains 115 images of Earth, greetings in 55 languages, including Akkadian, extinct for 2 millennia. 90 minutes of music ranging from Bach and Beethoven to Chuck Berry and Senegalese percussion, and the sounds of Earth: rain, surf, thunder, whales, a mother's first words to her newborn. The cover is engraved with instructions for use expressed in pulsar coordinates and binary notation, a best guess at a language legible to any intelligent species with no knowledge of human convention. Voyager 1 will not make a close approach to another star for roughly 40,000 years. The odds of the record being found are, in any practical sense, negligible. That is somewhat beside the point. The record is a declaration, encoded in gold, sealed against the cosmos, that we existed, that we wondered, and that we considered the possibility of not being alone seriously enough to say something about it. The farthest object humanity has ever launched carries, above all else, a record of what it feels like to be human. Voyager 1 will go silent eventually. The plutonium will decay past the threshold needed to power the transmitters, and the spacecraft will continue outward in permanent silence. Before that happens, it has already given us something permanent: the knowledge that human instruments have tasted interstellar space, that the hum of the galaxy is real and measurable, that the edge of the solar system is sharper, and the universe beyond it more structured than we assumed. It was sent on a short errand, and turned the errand into a voyage. It went further than anyone planned, found more than anyone expected, survived longer than anyone thought possible, and is still out there now, listening, transmitting, drifting through a universe that was here long before us and will be here long after. That we managed to hear even a whisper of it is, by any measure, extraordinary.